Happy 4th of July. We're talking about fireworks today. As we see fireworks all over the place, well, at least in America, we see all these colors, these shapes, loud sounds. But what are fireworks? So, fireworks are what's called a low explosive pyrotechnic device. So, it's not an extremely powerful explosive, and it's something that contains chemicals that's used to create some kind of visual display. That's essentially what they are. Let's get into how this works. So, what's on the inside of a firework? So, there's a few things that are really important, and I thought were very interesting. So, first off, we have a fuse. Okay, that's what we see. We light it on fire so it can explode. We have a shell, and this shell is what we see. If you ever use a firework, the outside part, that's the shell. The inside is called a mortar, and the mortar is just the explosive material, maybe with some sand around it or something like that to keep it in place, and that's a mortar. Now, what gives the fireworks its color are these things called stars. Stars are it's a collection of material that is usually made of some chemical compounds, and when this firework explodes, that material releases light, and that light is processed to us as color. So without the stars, you're not getting the pretty fireworks. Underneath the stars is gunpowder, and that's the main source of the detonation. And so you have two of these sections here. The first section is the bursting charge. The bursting charge is what explodes and ignites the firework itself. Right below that is the lifting charge, and the lifting charge does just that. It explodes and shoots the firework in the air. So that's what's on the inside of the firework. Now let's talk about how these things turn into what we see in the sky. Fireworks have a lot of different colors, from red to purple to all these crazy colors that we see. And these colors come from chemical compounds. Most of them are what's called salts. A salt is what's called a positively charged, it's a cation, and a negatively charged ion called an anion. These cations tend to be metals. So sodium, potassium, calcium, for example. And these anions, will be other, chloride or nitrate or things like that. Regardless of all this, a salt is a metal, usually combined with a negative ion. So sodium chloride, for example, is table salt, and other things like that. So the color red comes from strontium salts, orange from calcium salts, yellow from sodium salts, green from barium salts, blue copper salts, purple is copper and strontium compounds, silver is magnesium and aluminum compounds. Even if you didn't understand this little salt diagram, it doesn't matter. All we see is these colors come from chemical compounds, and they look pretty when they explode. That's the whole point. So how do fireworks create light? All right, so some quick physics. These chemical compounds have electrons in them. These electrons are negatively charged, and they have what's called a ground state energy level. It's like the basic energy level. If you put some energy into these compounds, those electrons might get a little excited, and if they get excited, they jump up in energy. Think about a little kid. You give them some sugar and they start shaking and moving around. This is essentially what electrons do. They vibrate and vibrate and vibrate, and this explosion gives them energy. And when they get that energy, they jump up to this very high energy level. They go from normal to this very high level. And it's not very long lived. And almost immediately, it'll jump back down to the low energy level, because you got the ground state, low, and you got high. It jumps to that low energy level. When it jumps down one, it emits photons or light waves. It emits light And in my sunscreen video, I talked about how light comes in waves. And these waves, the tops of these waves, have distances between them, like wavelengths. I talked about the ocean, right? The ocean has waves, and all those waves are is energy moving through water. And this is what light is. It's energy moving through air. And that energy is perceived to us as color. So when these fireworks explode, those waves go out and we see that as color: reds, oranges, blues, purple. I said in the last video, color in general is these wavelengths of light. So that's how they create light. Right? Just because it explodes doesn't mean it's necessarily going to make some color. Okay, but light is energy, and that's why light comes out of things when there's a strong reaction. So the next thing I want to talk about is the sound you hear and the shapes you see. So the sound is interesting. When fireworks go off, it creates this boom because the particles in the explosion often move faster than sound, which breaks what's called the sound barrier. Now, the sound barrier is not an actual barrier, but here's what it is. Imagine you're running a marathon and there's about 10 or 12 people in front of you. And as you're running, you're catching up to those people. But you can't just move through them. Usually if it's a clogged up group of people, you got to move around them or try and squeeze past everyone to get ahead of them. But you have to move through them. This is how the sonic boom works. So we have an example right here. You have a jet that's moving slower than sound, but as it gets faster and faster and faster up to the speed of sound, it catches up to those sound waves, just like the runner catches up to that group of people. But it's got to move past the sound waves. And as they collect and collect and collect and collect, the jet moves past them and moves through them. And as it moves through them, it creates this boom because it's moving through this collection of sound waves. And now the jet is faster than the speed of sound. And this is what it looks like if you have a high frame camera. I don't know anything about cameras, but anyway, this is a jet that's moving faster than the speed of sound. This is the sound, quote unquote, barrier. So that's how that works. And these molecules, particles, move so fast it creates that boom because it's moving faster than those sound waves. Now the shape is just the arrangement of the stars. So the stars are arranged in certain patterns in the firework that create patterns when it explodes. I don't know how all that works. This is just what I did for my research, and that's what I found. I thought it was interesting, but I'm not a pyrotechnic expert, so I can't go into all that. So anyway, that's fireworks. So summary, we talked about what's in a firework, those stars that give the firework its color, the different charges that shoot it in the air, that explode it, and things like that. And the colors coming from all these different chemical compounds. And when they explode, they give us color because those electrons get excited and it emits those light waves. And those light waves are perceived to us as color. And it makes this boom because those particles move faster than the speed of sound, and the shape comes from the collection of those stars, those collections of chemical material. As you arrange them in certain ways, it'll give you certain shapes, which I think is really interesting. So I hope this video was intriguing and kind of answered some questions as to how fireworks work. There's a lot more specifics to it, but that's for another video. I hope you have a fun 4th of July. Please be safe because people get their fingers blown off and all kinds of stuff. So don't do too much, but have fun. Thank you for watching, listening. Please like, comment, and subscribe. I'll see you again with another video.